doesn't sleep. It's just Thomas Jacobs.
Who's that?
He's the kid in my math class today who didn't sleep in like 3 days, so he's super drunk. Oh my god, I got so many good quotes out of him.
He's kind of weird.
So we need to smuggle this food into Sodexo.
Did we have anything to do this weekend? Like lab redos or quests?
I hope not.
I don't think we did. But I also didn't check.
Are we starting a new unit today?
No.
We are? Okay, I'm gonna make a new document then in the notes.
Wait, I'm not there.
You don't need to be there, Dwayne. We can start without you.
Wow. Okay, I started. There's a new document. I'm gonna name it something.
I'm gonna name it.
I already named it.
What'd you name it?
Something. Uh-oh. Kambukan. Oh, are we going to go into magnetism and light?
Yeah. Hold up. Let me read it.
What did he call it? Oh, earned it.
So we're missing video? Okay. Alright guys, we're gonna have your attention please. Sorry for the delay. My cell phone went off about 10 minutes ago. It was my basement calling me saying I'm flooding.
Oh.
So I'm going to get you guys started. And then Mr. Reich will come in and sort of supervise. But a lot of things to cover, so I'm going to need your cooperation. Something a little different here this last month. We're going to have a project.
Woman.
All right. Then we have to introduce fields and ways, right? Because you guys are starting on a quest assignment that is due, and then you have your fields lab on, which is due Saturday. A couple of you got started on it, but most of you need to take that data. Last I checked, everything was set up, temperature equilibrated, and I'll double check before I go. All right. What do you think of when you think of the quintessential scientist? What image comes to mind?
Richard.
Lab coat. So it's just giant lab coat like a ghost floating around.
Richard Feynman.
Richard Feynman. All right. Do you know what he looks like?
Yeah.
You do.
He's my favorite person.
Bill Nye. Okay.
Richard Feynman.
What do you guys think?
Fine. I'm feeling pretty fine, man.
Someone with glasses, big, thick ones. Like that.
I feel offended.
All right.
Do you know what he looks like? Yes, I do. He's only the coolest person ever.
Okay. That's kind of our stereotype, right? But we want to convey the fact that scientists come from all shades, all genders, every type of person you can imagine. Little quiz here.
Oh no.
Anybody recognize this man? No? Not at the tip of your tongue? You sure?
Let's see.
Has anybody heard the name Bose?
Oh.
Yeah. Now you may be thinking of his son and the speakers, right? But this is Dad. Dad was had some great ideas, had a hard time getting recognized. People wouldn't take him seriously because he didn't fit that picture, right? He didn't have the lab coat, the thick glasses. Well, I guess he did have the thick glasses. He had like one of the three going. All right, let's try another one. Ooh, this one looks a little bit different.
Is that?
You've seen this one?
I've seen.
I saw these in the quiz I took.
Oh, is that the guy from the genetic?
No, it is not.
I mean, he looks like a monk.
Okay. All right. His garb is a little bit different than the lab coat you were imagining. All right. This is Ramachandra. And he kind of knew he was onto something big, even if others didn't. He booked his passage to the Nobel Conference before he got his acceptance. All right? One last one. Apologize for the resolution. I'll stand back.
Rosalind Franklin. What was the girl named?
Sorry?
Carrie? Is it
That would be a
Carrie?
decent guess.
Rosalind
Same generation, maybe. What do you think? One generation apart. When you think atomic bombs, do you think of this picture?
No, I think Richard Feynman.
Right? You think of the guy with the white lab coat.
I think of Richard Feynman and
She
Oppenheimer.
did preliminary groundbreaking research shooting neutrons into atoms and making them unstable, and then noticing that the masses didn't quite add up. All right? And so later Einstein's going to put a number on that, E equals mc squared, but she started it all. And she's a woman. She was a Jew. She was working in Germany. And those things just didn't work out in the 1930s. So she survived and continued her work. But other people were happy to take credit for what she'd done. Other people shared in Nobel Prizes that left her off. Okay. So what is the take-home message? Scientists can look like anything. They can wear anything. They can be any shade of color. They can come from any country. Your assignment is to form groups of 2 or 3. Find such a scientist that would be inspiring, maybe their background, they don't
Richard
fit
Feynman
the
was
mold,
Jewish.
etc. So the 3 things: what is their biography? What have they done? And how has their work impacted us? All right. Now we're going to have a poster session, the second to last week of class. So I want you to take about 2 minutes and sort of brainstorm. Do you know a scientist? First off, form your groups of 2 or 3, okay? And then I want a list on the board.
Fine. Let's go. Do it. Come on. Let's do it. Let's do it. Let's do
You
it.
okay with Feynman?
Let's do it. Let's do it. Let's do it.
Dwayne,
Let's do it.
you okay with Feynman?
Come on.
Okay, go.
Come on.
Go!
I don't have handwriting. Come on before
Are you 2 groups of 2? Because I have that quicker before. Do you guys have to raise for action? Yeah, but there's some backwards. I got about 10 more minutes. I'm going to hand that up there. And so just need to I don't understand people. Let's see. Okay, I'll leave the list on the board as you work, in between, your lotion treatments and things. You can put that on the, I'd appreciate it if you have it on the board today. I'll have Mr. Wright take a picture of it. If you don't get it to me today, that's okay, but next class, Thursday, I would expect you to have a pretty good idea. All right, we want to talk about fields and waves. That is our new unit. Can somebody tell me what a field is? Give me an example. Maybe we can come up with a definition. Go ahead.
So it's
Hey guys, let's listen to Tyrone.
throughout the entire universe, there's an underlying set of numbers for each position in the universe.
Okay. So it's a set of numbers
for every position, and each position
associated with schools.
every position has a set or a specific value that changes over different times.
It could be time dependent. Okay, now he's given us a very, very somewhat esoteric example. Now you guys think of the news. Think of the local news. If you watch it for the whole 30 minutes, about 20 minutes into it, just before sports, they're going to flash you pictures of fields. What exactly were they? Take a moment to talk to each other.
I think he's talking about the snow.
The snow?
Yeah, remember, like, if, like, the TV's not working and it's going
I don't think that's what he's talking about.
Well, I don't know. I don't
think he's talking about the static.
Static, yeah, that's what people
Okay, let's hear some of those ideas. So we got this general definition. Points in space. Think of a grid if you want. Numbers associated with it. What was I sort of leading you to? What examples do you see on the local news? 20 minutes into it.
We're in the IMSA bubble, we don't watch it.
Sorry? The report. And so they have a microphone. And so behind me, I've got this big chart. It's like positions in space and numbers. Oh, a map of what? What are we talking about? Weather. Okay, so let's make our grid here. So let's say that this is the local area. Actually, NBC's weather ball radar, whatever, is actually kind of in my neighborhood. But so you've got the lake, and then you have these communities. It won't necessarily be evenly spaced exits. They might say Naperville or Aurora or whatever, and then they give you a number. So we can say, like right now, let's say it's 52 degrees in Naperville and 53 in Aurora, and maybe 51 in Plainfield. Okay, that is a field. It's a series of numbers associated with points in space. Now, we tend to be a little more organized. We like to have a nice grid. We don't like to put them kind of in random locations the way town centers might be. But this is a scalar field. These are just numbers and a position in space. Okay. Have we thrown out the word vector before? No. Have we used any vectors even if we haven't unwittingly said it? Sorry? Everything. Is mass a vector? Mass? Time? Temperature? Those are scalars. But tell me something that has not only a number, but a direction. Velocity. Speed. Okay. So speed we need to know. Velocity. Going back to the news example and our grid, our map of the Chicagoland area, what might, instead of temperature, be a vector field? Oh, such and such is out of the southwest.
Wind?
The wind. Okay, so we could have a vector field. So scalar field was temperature. Vector field. So we might say the winds were out of the northwest. Here in Naperville, they were gusting to, say, 4 meters per second. Aurora was 5. And then as we went further south, say Kankakee or whatever, it might have been a little slower, 2 meters per second. But now they were due west and east. Okay? So a value and a direction. That's a vector field. All right. Lab 1 is a little bit of a mix of things, right? We're going to look at magnetic fields, vector fields. We're going to look at scalar fields like temperature, and we're going to set them up in various ways. We've got a lava lamp, we've got some glass sitting on a hot plate, so to speak, and the second one on top filled with ice. So we make a gradient, we make this progression that we're going to map. All right. Let's do a really simple example. Let's say you can imagine yourself 6 weeks from now just chilling by a pool, right? So here you are. You get up at the crack of dawn. What's that, like 10:45? And you go out there, and you're 37, but you don't feel like you're in the bathtub here. But you take a measurement, like, oh, here at the top, we're 30 degrees C. Yes, that feels nice. And then we go down to the bottom. Let's say this is a 10-meter pool. And, it's only 20 degrees down there. We haven't turned on the pumps yet. It's circulating. And then for fun, as we're pulling our thermometer back, we see halfway down, all right, that's 25. As you might expect, you might say, this looks kind of like a lithium. Okay? So now, without, because you're pulling it out, you accidentally break it. And your mom is like, this is summer, you shouldn't forget all your SI physics. So figure out for me, at 7.25 meter depth, what the temperature is. Okay? So, 7.2 meters. What would you interpolate, what would you estimate the temperature? Talk to the people at your table. 20 degrees Celsius.
It looks like it's going to be like 24.
Why shouldn't
That's where it is.
That's why.
It's where the hold on.
Wait, below. Yeah.
23.8.
It looks like you lose a degree every time. It's so like
23.8. Yay, I was right.
I was looking at the past.
I'm imagining that
20.
corners.
Irish-San.
I think I've got an extra phone.
Wait, can I see it?
Done.
It's not Yo lemonade, it's Joe's lemonade.
No, that's
Ni hao buhama. Sana
Why not? But it's not Yo
all
lemonade.
right.
Joe.
How did you figure out what the temperature at that location is? If you had to go to the store, get a new thermometer, come back and measure, what would you predict the temperature at that location would be? Sorry? So had I said 7 meters, then you're right. It would have been 1 degree for every meter. But I didn't say exactly 7. Right? I said 7. So what does that do to it? Sorry? 22.8. So we're a little deeper. We're a little on the colder side. I would agree with that. 22.8. Now, supposing it wasn't such a nice example, supposing it wasn't 1 degree, can we come up with a mathematical equation that would get us this? What would that equation look like?
Y equals negative x plus 30.
Does that indeed work? So we had a slope of 1 degree per meter. And it was, as we, well now, how do you want to measure it? I was measuring it from the top. And that is what you are doing as well, right? So you're taking the 30 degrees and you're subtracting from it the depth, 7.2 times the degree. So, yeah, that absolutely works. Does everybody agree with that? Diane's nodding. Anybody not sure how to proceed if it was a little tougher than that? Okay, so now your mom's happy. She says, okay, you can have a snack. But then your dad comes home for lunch. He doesn't do it, but he comes home for lunch. And he's in a that was too easy. All right. So now, I'm thinking of getting a deeper pool. What if this was like fishing? All right. So instead of interpolating between points we have, he wants you to extrapolate beyond the data that you have. So let's go down to, say, a depth of 50 meters, right? About half the average depth of Lake Michigan. What would you predict the temperature would be there?
Which would make less sense because it's
Okay. So, can we use the same equation? It seems mathematically to work. You put in, what number do you put in? For x? We put in our 50 meters, we have the negative sign in front, we get the answer, what? Okay. So, you have correctly extrapolated. Is this realistic? No. We wouldn't be below freezing, right? And even if I picked a number above freezing and then said, okay, now extrapolate halfway to the center of the earth into the mantle, obviously, this represents local conditions. So, interpolating in here, not bad. Extrapolating a little bit beyond, it's probably okay. But the minute you get far, far away from your data, you should be concerned. It is likely to fail. Okay. Now, so that's probably as much as you need to know to do the lab. There are temperature guns, pistol grip. And you can turn on the laser to make sure you're pointing where it should be. Yes? Now, be careful, don't shine that in people's eyes. And also, be careful about reflections, because even if you said people are over there, you hit something shiny, it can bounce back. So just be thoughtful. The other thing is all our temperature gradings are up and down. And this temperature gun sends out a little bit of a cone, right? So it's averaging. And if you use the laser and hold it like you would expect to, you're always going to be offset a little bit. So you'll get the progression, but it will be shifted a little bit. So I'm telling you, go gangster style. Go sideways so that your laser is at the same height level, temperature that you're trying to measure. And then get sort of close to it, but you don't have to touch it. But don't be like backing away or moving in as you do. Just pick a distance and go up and down. Now, all right, before I turn you loose, right? So you got the lab that's due Saturday. You have the quest that's due Thursday. But I also have your test for you. Now, I'm not going to be here to collect it. Mr. Reif hopefully will collect it. But if he doesn't remember, please do not walk out with this. One, they're not in power school yet, and I don't want to put any like a zero there. So just be thoughtful. If you're worried, put it face down in the middle of the table as opposed to like under your stack of postage. So anyway, you can work on corrections, you can work on the lab. I recommend the lab, at least taking your data today, and then the quest. So I see see you guys on Thursday. I apologize that I have to run. I expect to be back before the day is out, so if you have burning questions, you can certainly find me later or email me. Even if I'm at home crying over a flooded basement, I'll still try to answer.
Need to change how Okay.
None of your business.
Okay.
Every single time you get the level 1 question wrong.
No, we're
Did you get 2?
I didn't know.
Did you get 5?
I got half.
Oh, me too!
It was really easy.
Did you get the last question?
I don't think so, no. Did you get it?
No.
Did you get the last one?
I got 7.
I got 85.
Does one of you have a fix?
I got everything
Check
but
the
the
front of yours. I think there were 2 fixes. I'm holding one.
Well, my
Does somebody else have a fix? Check the front, please. Do you have a fix? Okay, we're good then. Do you have a fix?
Do you guys want to go
Okay.
do the
Can you-
live?
Duh.
Wait a minute. I have to check something.
Should I put the document in? I'm ending the stream, okay? Well, too bad. I'm gonna do it anyway because it takes so much battery.